Okay, a very good morning, madam. I'm Naavind Balan from FPKE 31, RY31. So my matric card number is 2112911019. So today I would like to present about the electrical power system lab 2 analysis on line performance of the transmission line. So so these are the objectives and then the introductions. And then for the task 1 pre-calculation pre-lab calculation I already done before. The the question is 345 kilowatts three-phase transmission line is 130 kilometer long and the resistance per phase is 0.036 ohm per kilometer and the inductance per phase is 0.8 millihenry over per kilometer. The shunt capacitor is 0.0112 microfarad per kilometer. The receiving end load is 270 megawatt with power factor is 0.8, lagging at 325 kilowatts. Using the medium line mode to find the voltage and the power at sending end and the voltage regulation. So as mentioned on the above, so these are the calculations. So for the resistance, capacitance, and then voltage, length, and then the frequency, and then the power factor. So just substitute into the formula. So for the Z R plus with J 2 pi frequency times with micro inductance. So then we'll get a value. So after that z times with the length to get the z value z times with l, so I will get this value 4.68 plus j 39.26. And then for the capacitor value already substitute, and then the y, to find the y, j omega l, so the formula is j 2 pi times 61.46, and then the I current formula is V equals to 3 times with voltage 3 phase. So the VR equals to V over 3. So I will get this, and then the VS. So I just substitute in the formulas, and then to get A, C, and B. And then IS equals to VR plus RIR. So the formula of current is I equals to VR, just plus with the value. So and then same, the power factor is cos the 25 over here, just substitute with the positive one because lagging. So 25.43, and then the Vs V del VR plus B AVR plus with BIR, so the value, and then the Vs, so the formula is the SB times with the C3, and then the formula for QVR and then PS all over here I didn't mention. So same goes here, the formula, the calculation. So already substitute three phase inductions and the current Z and then the Y value into the formula to get the value over here. And then the calculation for capacitor also I already mentioned over here. Just substitute it, and then the calculations for the ABC is 1 is over here, 2, this value I will taken from here, and then this value I will taken from here, this one from here, and then the value of this are also taken from here. So just times with PS, I will just substitute 1 into 2, I will get it as equals to 4.28. So same power factor, and then value is normal cos tangent QR over PR, and then PR equals to 3 VR over IR cos. So the value is 232.1 megawatt millivolt, and then IR I get 453.7, and then as usual we are at the no load, we are dVs over A, so the value is over here, and then I get 5.504%. So this task, writing the MATLAB command. So a three-phase induction transmission line is 130 kilometer long, and then the resistor per phase is 0.0, as already mentioned, same as on the above. So this one we need to use the MATLAB. So the voltage power at the standing end of the voltage regulation. So types of having M5 window, save it in your own folder. So already the value of R, G, and then the frequency. So the inductance is 0.8, and then the capacitor is 0.0112, then the length is 1.130, and then the V phase equals 325. So just substitute the values into the formula. VR equals to VR 3 phase divided by square root 3 times with j omega 0. So YABC is the formula is like this: RLC to ABCD. So RLCGF length. So same goes here, and then the ABC formula is VR, and the I have to find the value. Then VS equals to VS over IS, V 3 phase square root times with ABS VS. Then to get the all the output, we need to print F to get this IS, VS, PS, QS, and percentage voltage of the regulation. So I already insert it, and then I will get this value as an output for the ABC over here, and then the IS, VS, PS, because we multi-mention about the F print. So the value will be get like this Z, and then Y, and then ABC. So IS I get 0.869657 power factor. For the power factor, the current is 421.132 ampere, and then the voltage 345, and then the phase PAS equals 218.85. Then the percentage voltage regulation 7.30913. So same here, the value insert over inside the formula, VS, IS, S, all the value over here as that, and then the print F value to get the output. So for the output, I will get like this value: ZF, ZY, and then the ABC, and the IR, VR, PF, and then percentage voltage. So from here, I'm learn about this. I will discuss about this lab is from this experiment. The load flow analysis tools developed from this lab use the Newton-Raphson approach to address the power flow problems. At the same time, the capacitor banks are used to balance the transmission lines for the loaded and unloaded stress, boosting line load capacity and achieve the input power level for weakened voltage buses. The operations of this system is tested in steady state setting. The line parameters and performance has been evaluated using a variety of MATLAB tools. So from here, a transmission line voltage regulations is measured the difference in receiving end voltage between the conditions and no load and at full load. There are three fundamental electrical characteristics for any transmission line. So for the discussion, for the conclusion, these experiments to understand the line performance of the transmission line model based on the pre-calculations. This experiment carried out to verify the calculations by comparing the results in MATLAB program. In this example, learn the basic programming of MATLAB using M-file editor that can be used in power system analysis. At last, the objective of this estimate is achieved as mentioned about the above. So we need to achieve the three objectives. So to understand the line performance of the transmission line model, to verify the calculations by comparing the results in the MATLAB programs, to know the basic programming of MATLAB using M5 editor that can be used in the power system analysis. The basics three I already achieved for the conclusion part. Thank you, madam.